There's an island that was not there 50 years ago. Tonight we watch it being born. Hello there and welcome to the Sleepy Science Facts channel. Tonight we are drifting toward land surrounded entirely by water. Islands. Not simply the tropical paradise that the word most easily conjures, though those exist and they are extraordinary in their own right, but every kind of island. The ones rising from active volcanoes on the ocean floor right now. The ones that appeared above the waves within living memory and are still growing. The ones that will disappear beneath the sea within this century. The ones so remote that the species living on them have never encountered a land predator and have forgotten how to feel afraid. The ones whose rocks are billions of years old, survivors of every catastrophe the planet has produced. The ones whose human cultures developed in complete isolation and arrived at solutions to the problems of living that no one on the mainland ever thought of. The ones that exist only at low tide, appearing and disappearing with the rhythm of the moon. Islands cover a small fraction of the Earth's land surface, but contain a disproportionate share of its biodiversity, its unique cultures, its endangered species, and its most extreme geological phenomena. They are natural laboratories where evolution, geology, and human ingenuity have each been running experiments in isolation, and the results of those experiments have changed our understanding of life, of the planet, and of ourselves. In this video, we are going to cover islands in every sense of the word. Every origin, every mystery, every creature, and every force that makes these surrounded pieces of land among the most scientifically extraordinary environments our planet produces. This is a complete and unhurried journey through the world's islands, from the volcanic newborns of the Pacific to the ancient continental fragments of the Indian Ocean, from the ice-covered giants of the Arctic to the coral-built atolls of the tropics, told at a pace that lets the details settle and the wonder breathe. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. Let your body soften and allow your breathing to slow, and allow the day to gently fade away as we explore the mysteries of the world's islands together. Let's begin. Islands are born in several completely different ways, and understanding how an island formed tells you almost everything about what you will find when you arrive there. Volcanic islands form when magma from the mantle or from tectonic hotspots breaks through the ocean floor and builds upward layer by layer until it breaches the surface. Continental islands form when rising sea levels, tectonic subsidence, or erosion separates a piece of land from a larger landmass, leaving it surrounded by water with flora and fauna derived from its continental parent. Coral islands and atolls form when coral reefs grow upward around subsiding volcanic islands, eventually leaving only the reef when the volcanic rock has sunk below the surface. Barrier islands form along coastlines from the accumulation of sediment carried by waves and currents. Each formation mechanism produces an island with a different age, a different rock type, a different relationship to the seafloor beneath it, and a different starting point for the ecological story that follows. A volcanic island in the middle of the Pacific begins as bare rock with no soil and no life, and everything that lives there arrived by crossing the ocean. A continental island like Britain began with an established ecosystem inherited from the mainland, and has been slowly diverging from it since the land connection was severed. An atoll is a biological structure built by living organisms over thousands of years on the submerged foundation of a volcano that no longer exists. The same word, island, covers origins as different as fire, ice, biology, and the slow sinking of the sea floor, and each origin produces a world unlike the others. The Hawaiian Islands were built by a volcanic hotspot, and the chain of islands records a movement of the Pacific plate across that hotspot over millions of years like a timestamp printed in rock. The Hawaiian hotspot is a region of anomalously hot mantle material rising from deep in the earth and melting through the Pacific plate above it to produce volcanic eruptions at the surface. The Pacific plate moves slowly to the northwest at about 7 to 9 centimeters per year, and as it does, the hotspot punches through it in successive new locations, building a new volcanic island each time, and leaving the older ones behind to erode and eventually sink beneath the surface as the plate carries them away from the heat source. The result is a chain of islands and submerged seamounts stretching from the currently active Big Island of Hawaii in the southeast of the ancient, eroded northwestern Hawaiian Islands in the northwest, with ages increasing steadily along the chain. The Big Island is geologically young and still growing, with active lava flows from Kilauea adding new land to its surface regularly. Kauai, at the northwestern end of the main Hawaiian chain, is approximately 5.5 million years old, and has been eroded into dramatic valleys and sea cliffs that bear almost no resemblance to the smooth volcanic shield of a young island. Beyond the main chain, the Emperor seamounts extend further northwest as a line of completely submerged former islands, their progression in age and direction recording the movement of the plate, and a bend in the chain records a change in the direction of plate movement approximately 4 to 7 million years ago. The Hawaiian chain is a geological clock, and reading it requires only knowing the speed of the plate. The Galápagos Islands sit at one of the most extraordinary confluences of ocean currents on the planet, and that confluence is a reason the islands support life so unusual that it changed the history of science. Located in the Pacific Ocean about 1,000 kilometers west of Ecuador, the Galápagos sit at the meeting point of three major ocean currents, including the cold Humboldt Current from the south and the warm Panama Current from the north. This mixing of cold and warm water creates an environment of unusual productivity and thermal variability that has driven the evolution of species adapted to conditions found nowhere else in combination. Marine iguanas, the only ocean-going lizards in the world, dive into the cold Pacific to graze on algae, warming themselves afterward by basking in the equatorial sun in dense black colonies on the volcanic rock. Flightless cormorants, their wings reduced to useless stumps by thousands of years of evolution in the absence of land predators, dive for fish in waters rich with upwelling nutrients. Penguins, whose nearest relatives live thousands of kilometers away in Antarctica, survive in the tropics because the cold Humboldt Current keeps the water cool enough for them. Darwin's finches, 13 species derived from a single founding population that arrived from South America, have diversified into every available ecological role on the islands, with different species evolving different beak shapes suited to different food sources. When Charles Darwin visited in 1835 and later reflected on what he had seen, the evidence of common descent modified by local adaptation was so clear that it contributed directly to the theory of natural selection. The Galápagos did not just host unusual animals. They help produce the most important idea in biology. Some islands are so remote that the animals living there have never evolved to fear predators, and this fearlessness has made them extraordinarily vulnerable to the first predators that arrived with human settlers. Islands that formed far from continental landmasses and that were never connected to a mainland often lack the land predators that drive the evolution of fear and flight responses in prey animals. On these islands, birds evolved that could not fly because flight is energetically expensive and there was nothing to fly away from. Reptiles basked in the open without retreating. Ground-nesting birds laid their eggs in exposed locations without concealing them. When humans arrived, bringing with them rats, cats, pigs, goats, and dogs as deliberate or accidental introductions, the result was catastrophic for species that had no behavioral or physiological defenses against predation. The dodo of Mauritius, famously extinct by the late 17th century, was a large, flightless pigeon that had evolved on an island with no land predators and showed no fear of the sailors who arrived and killed it for food, reportedly walking directly toward them. The great auk of the North Atlantic, a flightless seabird that nested on remote North Atlantic islands, was hunted to extinction by the mid-19th century partly because it had no instinct to flee approaching humans on land. The story of island species and introduced predators is one of the most consistent and most tragic patterns in the history of conservation, playing out on virtually every island humans have ever settled and continuing today wherever rat and cat eradication programs have not been completed. Iceland is one of the most geologically active places on Earth, sitting directly on both the mid-Atlantic ridge and a volcanic hotspot, and it is one of the very few places where a mid-ocean ridge can be walked across on dry land. The Mid-Atlantic Ridge runs directly through Iceland, and the North American and Eurasian tectonic plates are pulling apart along this line at about 2.5 centimeters per year. The spreading is visible in the rift valleys that cut through the island, in the frequent earthquakes, and in the eruptions that occur along the rift zone with remarkable regularity. Iceland experiences a major volcanic eruption approximately every 4 to 5 years on average. The 1983 eruption of Elger and the 934 eruption of Laki were among the largest volcanic events of the past 1,000 years and had measurable effects on climate and agriculture across Europe and beyond. The 2010 eruption of Geological produced an ash cloud that disrupted European air travel for weeks. The 2021 eruption at Fagradalsfjall attracted hundreds of thousands of visitors who came to watch lava flowing in real time a short drive from the capital. Iceland also has the world's highest density of geothermal features, including geysers, hot springs, fumaroles, and mudpots, and uses the heat from its geological activity to provide the majority of its heating and a significant portion of its electricity. The island is being torn apart and built up simultaneously, and the balance between those two processes has been maintaining a landmass above the waves since the hotspot began producing it approximately 16 to 18 million years ago. Surtsey is an island that rose from the sea in 1963 during a volcanic eruption off the coast of Iceland, and scientists have been watching life colonize it from bare rock ever since. On the 14th of November 1963, fishermen off the southern coast of Iceland observed steam and debris rising from the ocean surface. Within days, a new volcanic island was emerging from the water, built by eruptions from a submarine volcano. The eruption continued for nearly 4 years, building the island to its maximum extent of about 2.7 square kilometers before the eruption stopped and erosion began reducing it. From the moment the lava cooled, Surtsey became one of the most scientifically valuable natural laboratories on Earth, a pristine new land surface with no prior biological history, allowing researchers to observe the entire process of ecological colonization from the very beginning. Bacteria arrived first, carried by wind and ocean currents. Mosses and lichens followed. Seabirds began nesting, and their droppings fertilized the soil, accelerating plant establishment. Seals began hauling out on the beaches, contributing more organic material. Within decades, a soil had formed and flowering plants were established. The island now supports over 80 plant species and dozens of bird species that breed there regularly. Surtsey is a controlled experiment in how life assembles itself on a new surface, and every species that arrives, every soil layer that forms, and every ecological relationship that develops is documented as part of one of the longest-running ecological studies in the world. The island of Madagascar separated from the African continent approximately 88 million years ago, and the species that evolved in isolation there over that immense period of time are so unique that the island is considered one of the most important biodiversity hotspots on the planet. Madagascar is sometimes called the eighth continent because its flora and fauna are so distinct from the rest of the world. Approximately 90% of its wildlife is found nowhere else on Earth. The island is home to all of the world's lemurs, a group of primates that evolved from a common ancestor that arrived from Africa tens of millions of years ago on floating vegetation mats and diversified into over 100 species in the absence of the primate competitors and predators that suppressed them elsewhere. It is home to the fossé, a cat-like carnivore more closely related to mongooses and the cats, which evolved to fill the ecological role of apex predator in the absence of any true cats or dogs. 2/3 of the world chameleon species live in Madagascar, along with an extraordinary diversity of geckos, snakes, birds, and invertebrates found nowhere else. The baobab trees of Madagascar, of which 6 of the world's 8 species are endemic, create some of the most iconic landscapes in the natural world. This extraordinary biodiversity is under severe threat from deforestation driven by agriculture expansion, and Madagascar has lost the majority of its original forest cover, making it one of the most urgent conservation challenges on Earth and one of the places where the loss of biodiversity is happening fastest. Coral atolls are among the most extraordinary geological structures produced by biology, and their formation involved a process that Darwin correctly deduced from first principles before any of the evidence was gathered. Darwin proposed in 1842, before the theory of plate tectonics existed, and before deep-sea drilling had confirmed what lay beneath atolls, that coral atolls formed through a 3-stage process. A volcanic island forms in the ocean, and corals begin growing in the warm, shallow water around its shores, forming a fringing reef. As the volcanic island slowly subsides under its own weight and the seafloor cools and sinks, the coral reef grows upward to maintain its position in the sunlit shallow water, becoming a barrier reef separated from the shrinking island by a lagoon. Eventually, the volcanic island sinks below the surface entirely, leaving only the coral reef growing on the submerged volcanic foundation as a ring-shaped atoll enclosing lagoon. When deep drilling was conducted at Bikini Atoll in the 1950s, the drill passed through hundreds of meters of coral before reaching the basaltic rock of the original volcanic island far below, exactly as Darwin's model predicted. The atoll sits on a volcanic foundation that has been sinking for millions of years, kept above the waves only by the continuous biological construction of the coral organisms growing on its surface. The islands of the Maldives, the Marshall Islands, Kiribati, and Tuvalu are all coral atolls, and they sit at elevations of only 1 to 2 meters above sea level, making them the most directly threatened land areas on Earth as sea levels rise. New Guinea is the second largest island in the world and one of the most biologically and linguistically diverse places on Earth, containing more distinct languages than any other region of comparable size. The island of New Guinea, divided politically between Indonesia on the western half and Papua New Guinea on the eastern half, supports an extraordinary range of ecosystems from coastal mangroves and tropical lowland forests through montane cloud forest to alpine grasslands and permanent glacier on its highest peaks. This altitudinal diversity, combined with the island's geological complexity and long history of isolation between its many mountain valleys, has produced a biological diversity of extraordinary richness. New Guinea is home to tree kangaroos, which are kangaroos that have re-evolved tree climbing ability, birds of paradise whose males display plumage and behavior of almost incomprehensible elaboration, and over 20,000 plant species, more than the entire continent of Africa. The linguistic diversity of Papua New Guinea, which contains approximately 850 distinct languages, roughly 12% of all the languages on Earth in a population of under 10 million people, is a direct product of the island's geography. The rugged mountain terrain of the interior created isolated valleys where communities had little contact with their neighbors for thousands of years, allowing their languages to diverge to the point of mutual incomprehensibility. The mountain barriers that prevented communication also prevented the consolidation of populations into larger political units, producing a patchwork of small, intensely local cultures that have maintained their distinctiveness to the present day. The Maldives are the lowest-lying nation on Earth, and the story of their possible disappearance within this century is one of the most visceral illustrations of what rising sea levels mean for human communities. The Maldives consists of approximately 1,200 coral islands and sandbanks arranged in 26 atolls in the Indian Ocean, with an average ground elevation of only about 1.5 meters above sea level and a maximum elevation of about 2.4 meters. The entire nation sits within the range of sea level rise projected for this century under current climate trajectories. The Maldives government held an underwater cabinet meeting in 2009 to draw international attention to the threat, with ministers in scuba gear signing documents on a table on the seafloor. The nation has been purchasing land in Sri Lanka and India as a potential refuge for its population if the islands become uninhabitable. But the threat is not simply one of eventual flooding. Saltwater intrusion into freshwater lenses beneath the islands is already affecting drinking water quality. Increased storm surge from more intense tropical cyclones is already causing damage to infrastructure and beaches. Coral bleaching driven by warming ocean temperatures is degrading the reef systems that protect the island from wave energy. The Maldives are not waiting for a distant future catastrophe. They are already managing the early stages of one, and the decisions being made about how to respond, whether to adapt, to protect, or eventually to leave, are being watched by every other low-lying coastal nation on the planet. The island of Greenland is the largest island in the world, and beneath its ice sheet lies a landscape of mountains, valleys, and lakes that has been hidden from the world for hundreds of thousands of years. Greenland covers approximately 2,100,000 square kilometers, and is covered by an ice sheet up to 3 kilometers thick that contains approximately 8% of the world's total fresh water. If the Greenland ice sheet melted entirely, global sea levels would rise by approximately 7 meters, enough to inundate coastal cities on every continent. The ice sheet is ancient, with the oldest ice at its base estimated at over 100,000 years old, and it preserves a climate record of extraordinary length and detail in its layered structure. But beneath the ice lies a land that has not been seen since before the Ice Age. Radar surveys and ice-penetrating measurements have revealed a landscape of valleys, fjords, mountains, and plains, some of them below sea level and some above, that would be a significant geographical feature if the ice were removed. The deepest valley yet discovered beneath the Greenland ice, called the Greenland Grand Canyon, rivals the Grand Canyon in the United States in scale, and runs for approximately 750 kilometers beneath the ice. The land beneath Greenland is responding to the gradual melting of the ice above it by rebounding upward as the weight decreases, a process visible in GPS measurements of crustal movement across the island. Greenland is not simply a block of ice. It is a continent-scale archive of climate history sitting on top of a hidden landscape that most humans will never see. The island of Borneo is one of the oldest and most biologically rich islands on Earth, and it is home to species so ancient and so strange that they have no close relatives anywhere else. Borneo, the third largest island in the world divided between Malaysia, Indonesia, and Brunei, sits on the Sunda Shelf, a section of submerged continental crust that was exposed as dry land during ice ages when sea levels were lower, connecting Borneo to mainland Southeast Asia and to the other large islands of the region. This periodically broken and restored land connection has allowed species to move between Borneo and the mainland during wet periods and become isolated during dry periods, driving repeated cycles of colonization and speciation. Borneo is home to the Bornean orangutan, a great ape that shares over 96% of its DNA with humans and that demonstrates tool use, long-term planning, and cultural transmission of learned behaviors between generations. The proboscis monkey, found only in Borneo, has a nose so large it hangs down over the mouth and is used by males as a resonating chamber to amplify calls, producing sounds with no parallel in any other primate. The Bornean pygmy elephant, isolated from its Asian relatives long enough to have diverged into a distinctly smaller and notably more docile form, lives in the lowland forests of the island's northeast. Borneo's forests also contain the world's largest flower, the rafflesia, as described in the plant script, along with pitcher plants large enough to trap rats, flying lizards, flying frogs, and walking catfish. The island is a biological compendium of the extraordinary, and it is losing its forests faster than almost any other place on Earth. Some islands exist only at low tide, appearing briefly twice a day before the sea reclaims them, and these tidal islands have a culture and a mythology all their own. Tidal islands are pieces of land connected to the mainland or to larger islands by causeways or natural land bridges that are exposed at low tide and submerged at high tide. Mont Saint-Michel off the coast of Normandy in France is perhaps the most famous, a rocky island crowned by a medieval monastery that becomes accessible by a natural causeway at low tide and surrounded by water twice daily when the tide comes in. The tidal range in the Bay of Mont Saint-Michel is among the largest in Europe, reaching up to 14 meters, and the incoming tide can move across the flat bay at speeds comparable to a walking horse, a fact that has historically made the crossing dangerous for pilgrims who misjudge the timing. Lindisfarne, or Holy Island, off the northeast coast of England, is similarly accessible twice daily and similarly significant in history as a center of early Christian scholarship and manuscript production. The tidal rhythms of these islands shape their cultures, their architecture, their agriculture, and their spiritual character. The knowledge of tides and the timing of crossings was practical survival knowledge, and the twice-daily cycle of isolation and connection gave these communities a relationship with the sea that was immediate, unavoidable, and integrated into every aspect of daily life in a way that permanent islands or mainland communities never quite experienced. The Canary Islands off the northwest coast of Africa are an archipelago built by a hotspot, and their volcanic history includes some of the largest volcanic collapses in geological history, which produced tsunamis of continental scale. The Canary Islands, belonging to Spain but located close to the coast of Morocco, were built by a hotspot beneath the African plate and contain some of the most dramatic volcanic landscapes in the Atlantic. El Teide on Tenerife is the highest point in Spain and the third tallest volcanic structure in the world measured from the ocean floor. The islands have experienced enormous volcanic collapses in their geological past, events in which vast sections of volcanic island flanks have failed catastrophically and slid into the ocean in a single event. The Canary Island collapse events produced some of the largest submarine landslides ever documented, moving volumes of rock comparable to small mountain ranges into the deep Atlantic. The tsunamis generated by these events are estimated to have been of extraordinary height, potentially reaching tens of meters on the opposite coast of the Atlantic. Whether a future collapse of the western flank of La Palma Island could produce a mega tsunami capable of crossing the Atlantic has been the subject of significant scientific debate, with some researchers suggesting the western flank shows signs of instability and others arguing that any collapse will be gradual rather than catastrophic. The debate itself is a reminder that the geological processes that build volcanic island archipelagos can also produce some of the most violent events in the Earth's geological record. The island of Sri Lanka has been a crossroads of human culture, trade, and conflict for over 2,000 years, and its natural history is as remarkable as its human one. Sri Lanka is a continental island sitting on the Indian plate, separated from mainland India by the Pork Strait, which is shallow enough that land connections existed during ice ages when sea levels were lower. This intermittent connection has allowed plant and animal species to move between India and Sri Lanka during wetter, lower sea level periods and become isolated during drier, higher periods, producing a significant number of species found only in Sri Lanka despite its proximity to the mainland. The island has one of the highest concentrations of endemic species per unit area of any island in the Asian region, including endemic elephants, leopards, and an extraordinary diversity of amphibians and reptiles. Sri Lanka has been inhabited by humans for at least 125,000 years, making it one of the most continuously inhabited islands in the world. It was a major center of the ancient spice and gem trade and was known to the Greeks, Romans, Arabs, and Chinese as a source of cinnamon, sapphires, and other luxury goods that reached markets across the ancient world. The name Serendip, the Arabic name for the island, gave English the word serendipity, coined by Horace Walpole in the 18th century in reference to a Persian fairy tale set there, meaning the faculty of making fortunate discoveries by accident. The island gave the world a word for finding something wonderful when looking for something else, which seems appropriate for a place that has always offered more than anyone expected to find. The Faroe Islands in the North Atlantic sit between Norway, Iceland, and Scotland, and their ecology and human culture have been shaped by one of the most extreme maritime climates in the inhabited world. The Faroe Islands consist of 18 volcanic islands with a combined area of about 1,400 square kilometers and a population of approximately 55,000 people, making them one of the most remote inhabited archipelagos in the world. The islands were settled by Norse Vikings in the 9th century, though Irish monks may have preceded them, and have been inhabited continuously since in one of the harshest environments in which sustained human settlement has been maintained. The climate is characterized by strong winds, frequent fog, rapidly changing weather, and temperatures moderated by the Gulf Stream, which keeps the island from becoming as cold as their latitude would suggest, but also keeps them perpetually overcast and damp. The landscape has been almost completely deforested since human arrival, and the windswept green hills and dramatic sea cliff that define the island's visual character are in part a product of centuries of sheep grazing that prevents woodland regeneration. The islands sit on the Faroe Island Ridge, an underwater ridge that plays a significant role in the global ocean circulation, channeling cold, dense water from the Nordic seas into the deep North Atlantic where it sinks and begins the deep circulation that drives the global conveyor belt. The Faroe Islands are a small dot in the North Atlantic whose geology is connected to the thermohaline circulation that regulates the climate of the entire planet. Islands have been the sites of some of the most extraordinary human voyages in history, and the settlement of the Pacific Ocean by Polynesian navigators is one of the greatest achievements of human exploration. Beginning approximately 3,000 years ago, Polynesian people began spreading eastward from the western Pacific into the open ocean in double-hulled canoes, eventually settling every habitable island across an area of ocean larger than the entire landmass of Asia. They reached Hawaii, Easter Island, and New Zealand, the three corners of the Polynesian Triangle, without compasses, charts, or any instrument other than their knowledge of the stars, the waves, the winds, and the flight patterns of birds. Polynesian navigators could read the swell patterns in the ocean, which carry information about distant islands that modify the swell's direction and shape as they pass. They could identify the time of year and their latitude from the paths of stars across the sky. They knew which species of bird could be found at sea and which only fly close to land. They knew how ocean currents flowed and how cloud patterns formed differently over land than over open water. The settlement of Easter Island, located over 3,500 kilometers from the nearest inhabited island, required navigating to a target less than 20 kilometers wide across an open ocean with no visible landmarks and no guarantee of finding anything at all. The people who made these voyages were not simply brave. They were in possession of a comprehensive navigational knowledge system that took centuries to develop and that allowed them to do something that seems, from the perspective of modern navigation, almost impossible without instruments. Easter Island, the most remote inhabited island in the world, was home to a civilization that raised nearly 900 enormous stone statues, and the story of how they were moved and why the civilization collapsed is still being revised. Easter Island, known to its indigenous Rapa Nui people as Te Pito o Te Henua, meaning the navel of the world, sits in the southeastern Pacific Ocean over 3,500 kilometers from Chile and over 2,000 kilometers from the nearest inhabited island. Between approximately 900 and 1700 CE, the Rapa Nui people carved approximately 900 statues called moai from the volcanic rock of the island's crater walls, some of them reaching heights of 10 meters and weighing over 80 tons, and transported them to platforms called ahu around the island's coastline. How the statues were moved has been debated and experimented upon for decades. Recent research involving experiments with replicas suggests the statues were walked in an upright position using coordinated rocking motions guided by ropes, a method that leaves tracks consistent with the archaeological evidence and that is captured in Rapa Nui oral tradition, describing the statues as having walked to their positions. The story of Easter Island's ecological collapse, in which deforestation by the growing population was thought to have caused societal collapse before European contact, has been significantly revised by recent research suggesting that introduced rats, European diseases, and slave raiding were far more significant causes of population decline than previously believed. The island and its statues continue to be re-examined, and every revision of the story makes it more complex and more human than the simple cautionary tale it had previously been reduced to. The Seychelles are among the world's last remaining granite oceanic islands, and their geological origin is unlike that of any other island group in the world. Most oceanic islands are volcanic, built from the seafloor upward by magmatic activity. The Seychelles are different. They are made of granite, a rock type that forms deep in continental crust and is not associated with oceanic volcanic activity. The explanation for their presence in the middle of the Indian Ocean is that the Seychelles are a fragment of the ancient supercontinent Gondwana, left behind when India and Madagascar broke away and drifted northward and westward respectively, leaving the Seychelles as a microcontinent isolated in the opening Indian Ocean. The granitic rocks of the Seychelles are approximately 750 million years old, making them among the oldest surface rocks in the entire Indian Ocean region. The biological consequence of this ancient continental origin is that the Seychelles have an endemic flora that is distinctly continental in character, including the coco de mer palm, which produces the largest seed of any plant in the world, a double coconut that can weigh up to 25 kilograms. The endemic species of the Seychelles, including giant land tortoises related to those of the Galápagos, unique birds like the Seychelles warbler, and extraordinary plants found nowhere else, are the products of long isolation on an ancient continental fragment rather than the products of recent volcanic colonization, and they carry in their biology the signatures of a geological origin that is hundreds of millions of years old. Islands are disappearing right now, and the communities that call them home are facing displacement from homelands that have existed for thousands of years. The coral atolls of the Pacific and Indian Ocean are the most immediately threatened land areas on Earth from rising sea levels. But the threat is not only a future scenario for the lowest-lying nations. Islands are already shrinking. Beaches are eroding faster than they can be replaced. Freshwater lenses beneath low islands are being contaminated by saltwater intrusion as sea levels rise and storm surges penetrate further inland. The 5 islands of the Solomon Islands that disappeared beneath the Pacific between 1947 and 2014, confirmed by analysis of historical aerial photographs and satellite images, were the first documented cases of inhabited islands being lost to sea level rise and coastal erosion combined. Kiribati, a Pacific island nation spread across 33 coral atolls near the equator, has been purchasing land in Fiji as a potential future home for its population. The government has adopted a policy it calls migration with dignity, aimed at ensuring that if the islands become uninhabitable, its citizens will have the skills and resources needed to integrate into new communities as contributing members rather than as climate refugees. The loss of an island is not only the loss of land. It is a loss of culture, of language, of place-based knowledge, of ancestral connection, and of a way of being in the world that took thousands of years to develop and cannot be relocated to higher ground. Island species have provided some of the most important insights in the history of biology, and the pattern that emerges from studying them reveals something fundamental about how life diversifies and adapts. The principle of island biogeography, developed by ecologist Robert MacArthur and E.O. Wilson in the 1960s, describes a relationship between the size of an island, its distance from the mainland, and the number of species it can support. Larger islands support more species because they offer more habitat types and their larger populations are less vulnerable to random extinction. Islands closer to the mainland support more species because immigration rates are higher, constantly restocking species that go locally extinct. The balance between immigration and extinction determines the equilibrium number of species on any island, and the theory has been confirmed by studies of rare islands, of habitat fragments in terrestrial landscapes, and of artificial experimental islands. Island species also demonstrate a consistent pattern called the island rule, in which large animals on islands tend to evolve smaller body sizes over time, while small animals tend to evolve larger body sizes, both converging toward a medium size that is optimal for the limited resources and reduced predator pressure of island environments. The island fox of the Channel Islands off California, descended from gray foxes, is roughly half the size of its mainland relative. The Komodo dragon of Indonesia, the world's largest living lizard, evolved to giant size on islands where it became the apex predator in the absence of larger carnivores. The island is not just a place where organisms live. It is a force that shapes them. The island of Cuba is the largest island in the Caribbean, and its isolation has produced a natural and cultural heritage of extraordinary richness that is unlike anything else in the Americas. Cuba sits at the western end of the Greater Antilles, the chain of large islands that includes Hispaniola, Jamaica, and Puerto Rico, and its natural history reflects both its Caribbean island character and its position as a stepping stone between North and South America during periods when sea levels and island configurations allowed faunal exchange. Cuba is home to the bee hummingbird, the smallest bird in the world, measuring about 5 centimeters in length and weighing less than 2 grams. It is home to the Cuban solenodon, a small insectivore that produces venomous saliva and is one of the most primitive mammals alive, a living representative of a lineage that has changed little in 76 million years. Cuba's caves contain the most extensive fossil record of Caribbean land vertebrates, documenting dozens of species that went extinct after human arrival in the Caribbean. Cuba's human history is equally extraordinary, as a crossroads of indigenous Taino culture, Spanish colonialism, African heritage, and the broader currents of Atlantic history, producing a culture, music, and architectural heritage that is distinctly its own. The island has maintained a degree of ecological integrity in its forests and reefs that many larger Caribbean islands have lost, partly through the circumstances of its recent political history, making it a significant priority in Caribbean conservation even as its ecosystems face growing pressures. The Channel Islands of California are a place where the natural world has preserved conditions that once existed across a far wider area of the Pacific coast, and where conservation efforts have produced one of the most dramatic wildlife recoveries in American history. The 8 Channel Islands off the southern California coast were connected to the mainland during ice ages when sea levels were lower, and large mammals, including mammoths, reached the islands by swimming or walking across the land bridge. Isolated on the islands, these mammoths evolved into a dwarf form, the pygmy mammoth, standing only about 1.5 meters at the shoulder compared to the 3-meter height of their mainland relatives, a clear example of the island rule in action. The pygmy mammoths went extinct after humans arrived, but their fossils remain as one of the most striking examples of island dwarfism in the fossil record. The islands are now a national park and a marine sanctuary, and their waters contain some of the most productive kelp forest ecosystems on the Pacific coast. The island fox reduced to fewer than 100 individuals on 3 of the islands by the late 1990s due to predation by golden eagles that had colonized the islands after bald eagles were eliminated by DDT, has recovered to several thousand individuals following one of the fastest endangered species recovery programs in United States history. The recovery required removing golden eagles, reintroducing bald eagles, and captive breeding island foxes, a complex ecological intervention that demonstrated both how quickly island ecosystems can collapse and how quickly they can recover when the causes of decline are understood and addressed. The most isolated island on Earth is Bouvet Island, an uninhabited Norwegian territory in the South Atlantic, and its isolation is so extreme that it exists at the edge of what the concept of remoteness can mean. Bouvet Island sits in the South Atlantic Ocean, approximately 1,700 kilometers north of Antarctica, 1,700 kilometers east of the nearest land in South Africa, and is surrounded by some of the roughest seas in the world. The island is covered almost entirely by glacier and has no permanent inhabitants. It was discovered by a French naval officer in 1738 and was not successfully landed upon until 1825. It is owned by Norway and designated as a nature reserve, but its extreme remoteness and hostile conditions make even visiting it a significant expedition. The island sits on the mid-Atlantic ridge and is of volcanic origin. Its extreme isolation means that any organism that reaches it, whether by air, ocean current, or human introduction, has crossed an extraordinary distance of open ocean to get there. Seabirds nest on the cliff ledges and seals hole out on the rocky beaches, and the waters around it are rich with the productivity of the Antarctic convergence. In 1964, a mysterious abandoned lifeboat was found on the island with no ship nearby and no explanation of how it arrived there, a mystery that has never been solved. The most isolated island on Earth keeps its secrets as effectively as you might expect from a place that has barely ever been visited. And so we drift gently back across the water, carried home on the same currents that carried so many of the species and peoples we visited tonight, carrying with us the quiet wonder of everything these surrounded pieces of land revealed. We watched a new island rise from the sea in 1963 and stood beside researchers counting every species that arrived to colonize its bare volcanic rock. We followed the Polynesian navigators across the largest ocean on Earth, reading the stars and the swells with knowledge built over centuries. We found flightless birds that had forgotten fear and paid the price, and giant tortoises on ancient continental fragments that had been isolated since before the dinosaurs disappeared. We descended beneath the Maldives to sign documents on the seafloor and understood that the most beautiful islands on Earth are also the most fragile. We visited Easter Island and found that the story we thought we knew was more complex, more human, and more hopeful than the simple warning it had been reduced to. We walk across Iceland on the spreading boundary of two tectonic plates and watch lava add new land to the Earth's surface in real time. We found languages on New Guinea that have been diverging for 10,000 years in mountain valleys a day's walk apart. We discovered that the island rule turns giants into dwarfs and dwarfs into giants, that coral atolls are built by biology on the foundations of sunken volcanoes, and that the lowest islands on Earth are already managing the early stages of their own disappearance. Islands are where the planet runs its most concentrated experiments, and the results are always extraordinary. They are the world in miniature, surrounded by the thing that makes them what they are, isolated by the very water that gave them life. If you enjoyed this sleepy journey, you could support the channel by liking, subscribing, or leaving a calm little comment before you rest. It helps more curious minds find their way here. And if you are still awake, there is another video waiting on your screen, ready to carry you onward into another corner of science. But for now, let the questions loosen their grip. Let your shoulders soften. Let your jaw unclench. Allow your breathing to slow, steady, and deepen. Picture a small island at night, the water all around it perfectly still, the stars reflected in the dark surface of the sea so completely that you cannot tell where the island ends and the sky begins. Everything quiet, everything held, the ocean breathing slowly in and out against the shore. You are surrounded by water on all sides, and there is nowhere you need to go. You only need rest. Sleep well, and good night.